Hello students, welcome you all to another video. Here we will discuss about the electromagnetic theory chapter. So first of all, we will discuss about del operator in the video. So before going to del operator, let me know what is a scalar quantity and what is a vector quantity. I think you all know about what is a scalar quantity and what is a vector quantity. Scalar quantities are those which have only magnitude. Just example, mass, temperature, all these are scalar quantities. Vector quantities are those which are both scalar, that means a magnitude, as well as a direction. If a quantity has a magnitude and a direction, that is said to be a vector quantity. For example, we consider force. If I told you 2 Newton force is given, 2 Newton means that represent only the magnitude, how much amount of force is given. Then towards east, if 2 Newton force is given towards east, that means 2 Newton is the magnitude and east is the direction. So all the quantity which have only magnitude are said to be a scalar, and the quantities which have both magnitude and direction, they are said to be a vector quantity. Similarly, scalar field and vector field. Scalar field means what? If entire field is represented by a quantity which is a scalar, like temperature, like mass, like density, like volume, if entire surface is represented by a function which is a scalar quantity, that is said to be a scalar field. That is said to be a scalar field associated with a scalar point function. And vector field what? Similarly, if entire function is represented or entire point or field is represented by a vector quantity, that is said to be a vector field. So scalar field and vector field are nothing where it represents each point of the field is represented by a scalar and each point is represented by a vector quantity. For example, if you consider temperature, temperature is given by a function x squared, x, y plus z. That means whatever the value you take x, y, z, that point represents particular temperature. So that is a scalar field. Similarly, if you consider any vector function is represented by this term, that is said to be vector field. That entire field or entire area is said to be vector field. So now we are going to discuss about del operator. So what is a del operator? So del operator is nothing but a partial derivative operator. Partial derivative, and is represented by del equal to del, since vector quantity we have to give vector sign, del equal to I cap del by del x, j cap del by del y, k cap del by del z. So I cap, j cap, k cap, already we know that x component, y component and z component. So it is a vector quantity or vector operator. Since I cap, j cap, k cap, you must have known that is a vector quantity. And del by del x represent the partial derivative with respect to x, then partial derivative with respect to y, partial derivative with respect to z. So since it is a vector quantity, we can multiply any scalar with a vector quantity. For example, if we consider a is a vector, we can multiply 2a. That means a scalar is multiplied with a vector. We can multiply 3 by 8a. 3 by 8a. So this is a scalar quantity we can multiply. So scalar quantity can be multiplied with a vector, and vector can be multiplied with another vector. You must have remembered dot product and cross product. If b is another vector, we can find out a dot b dot product, and we can find out a cross b cross product. So if a is a vector quantity, we can multiply with a scalar, we can multiply with a vector via two different methods. One is dot product, one is cross product. Same formula or same concept we are going to use for del also. Since del is a vector partial derivative operator, we can apply del over a scalar quantity, over a vector quantity, either in dot product or in vector product. Accordingly, they are named as gradient, divergence and curl. So gradient means what? When a scalar function is multiplied with del. Divergence is when dot product of del operator with any another vector. and cross product of del operator with the other vector is said to be curl. So we are going to discuss about each one of them, and also you will do some numericals so that you will get acquainted with this type of numerical. So gradient means what? Now, if phi is a scalar function, a scalar quantity, then multiplication of del operator with phi is said to be gradient. Gradient of phi, or simply you can write down grad phi. Grad phi. That means normally we just multiply. Then how to write the function? Del operator, you know that I cap del by del x. So del phi is equal to I cap del by del x, j cap del by del y, k cap del by del z, and phi is multiplied with it. Since it is normal multiplication, you can simply multiply phi with first term, phi with second term, phi with last term. Our result will be I cap del phi by del x, j cap del phi by del y, k cap del phi by del z. So this is the result of gradient of phi. So gradient of phi is nothing but I cap derivative of phi with respect to x, j cap partial derivative, all three are partial derivative with respect to y, partial derivative with respect to z. And gradient of any scalar quantity is always a vector quantity, because you can see I cap, j cap, k cap is there. So gradient is always a vector quantity. You must now remember the relation between electric field and potential. Electric field equal to minus dV by dr, electric field, or you can write down electric field is negative gradient minus grad V, not R, minus grad V. The relation between electric field and potential is negative gradient of potential. So this is said to be gradient. Clear? Phi equal to x y square z or x cube y square z. Let phi is given, and here it is given that calculate gradient of phi at a point 1, 2, 3. 1, 2, 3. That means first we have to find out gradient of phi. So gradient of phi. Gradient of phi means I cap del phi by del x, j cap del phi by del y, then k cap del phi by del z. And phi is here, I cap del by del x, x cube y square z, then j cap del by del y of x cube y square z plus k cap del by del z of x cube y square z. Then you have to just simply take the derivative, and it is partial derivative. So if we take the partial derivative, it will be like I cap. Here you can see derivative we have to take with respect to x. So x cube will be 3 x square y square z. Result we get for first term. Similarly j cap derivative with respect to y square is 2y. So 2 x cube y z plus k cap derivative of z with respect to z with respect to z will be 1. So result will be x cube y square. So this is the result we get gradient of phi, but the question has given a point at 1, 2, 3. So at 1, 2, 3 means at x equal to you can put 1, at y equal to you can put 2, at z equal to you can put 3. Once you put the values of x, y, z here, x, y, z, similarly here x, y, z value, x, y and z is 1 here. Once you put, you will get the result required for this question. I will give you some questions regarding this gradient. You have to prepare and let me know in the comment section the answers of each questions. Next we will go to the divergence. So divergence is what? Dot product. If any vector A is there, then del dot A. Del dot A is said to be divergence or divergence A. Div A. Div A means divergence of A. So you know that dot product of any two vector is also said to be scalar product. Why it is said to be scalar product? Now because the result of a dot product is nothing but a scalar quantity. Since the result is a scalar quantity, this is said to be a scalar product. So now our aim is to calculate what is del dot A. So del dot A, del we know that I cap del by del x, j cap del by del y, and k cap del by del z. Dot product with A, and any vector can be represented in terms of component, that is I cap ax, j cap ay, k cap az. Clear? Now we know that I dot product of I with respect to I is 1, I dot j is 0, I dot k is 0. So I dot I1, so you get del ax by del x. Then I dot j0, I dot k be 0. Similarly, j dot I0, j dot j1, so you will get plus del ay by del y, and j dot k is also 0. Similarly, k dot I0, k dot j0, k dot k1, so you get del az by del z. So this is the formula we get for divergence. So divergence of any vector is nothing but partial derivative of its components with respect to the parameter. That means del x by del x plus del ay by del y, del az by del z. Clear? And always remember one important thing here. If divergence of a vector is 0, then that vector is known as solenoidal vector. If divergence of a quantity is 0, that is said to be a solenoidal vector. If divergence of A is 0, then A is said to be solenoidal vector. Clear? Let's do one numerical, then we'll go to curl. If you have any doubt, you can ask me. You can let me know in the comment section. Let A is a vector which is given by I cap x square j cap y square x, k cap z x y, and question is given to find out divergence of A. So divergence means del dot A. So del by del x, directly I am writing del by del x of x component. So x component is here x square z plus del by del y of y component y square x plus del by del z of z component z x y. Directly you can take derivative. X square is 2xz plus derivative of y is 2yx, derivative of z with respect to z is 1xy. If point are given, like 2, 3 and 7 are given, then you can put the value of x, y and z, you can put to get the actual answer. Similar to that of the gradient, at the end you can put the values of x, y, z. I hope this is clear. Now we'll go to the curl. Curl is nothing but cross product of del operator. If we multiply, if A is a vector quantity and cross product of del with A, if we calculate, this is said to be curl of A. Cross product of del operator with any vector quantity is said to be curl. Clear? Now we are going to find out cross product. So del cross A. You remember that determinant formula? Determinant formula, we are going to use this one. So first we can write down I cap, j cap, k cap. Then whatever the first vector written here, that is del, its component we have to write. Del by del x, del by del y, del by del z. Then we have to write down the components of second, that is ax, ay, az. Del operator is nothing very simple as that of the vectors you have done. Del operator is nothing any complicated. It is simply as that of the dot product and cross product you have studied in your 11th and 12th class. So just you have to use the partial derivative vectors. So if you do that, then you can directly write down I cap is there. So I cap means we have to omit these two line, product of these two, del and this one, in bracket you can write down del az by del y minus cross product of these two, del ay by del z. This is our first term. Then second, minus j cap. So in j we can remove this one, del x by del az by del x minus del ax by del z, plus k cap we can remove this one, cross product of del x by del y, del ay by del x minus del ax by del y, del ax by del y, and here k cap. So I cap, j cap, k cap we get, and already we know that cross product of any two vector is also said to be vector product because its result is a vector quantity. So whatever the result you will get here, that will be a vector quantity. Clear? And one more important thing, remember, if curl of a vector is 0, curl of any vector is 0, then that vector is known as an irrotational vector. This is very important for short questions. What is irrotational vector? What is solenoidal vector? In numericals also you may get questions like that. Check whether it is irrotational or solenoidal. So if it is solenoidal given, that means you have to find out whether del dot that vector is 0 or not. If irrotational given, you have to just find out whether cross product of del with respect to the given vector is 0, that is irrotational. If it is not 0, then it is not irrotational vector. This is all about del operator. Then its scalar multiplication, that is said to be the gradient. Then dot product of del with any other vector, that is the divergence, and cross product of del with any vector, that is curl. Clear? Next, there are two very important theorems. One is Gauss divergence theorem, another one is Stokes theorem. So why we are going to study this theorem first? In physics, you know that we have to use calculus method, derivative as well as integrations. Do you remember Gauss theory, Gauss law or Gauss theorem? That is the net electric flux is equal to Q by epsilon naught. So electric flux means we have written flux equal to E dot ds integration over S. Similarly, Ampere circuit law you remember, B dot dl integration over C or L. Clear? Here you can see dot ds and integration over S. This is said to be surface integral. When integration is taken over area, that is said to be surface integral. But when integration is taken over line, this is said to be line integral. Similarly, volume is also there, because in 12th class you must have studied that continuous charge distribution. Continuous charge distribution of three different types. One is line charge density divided by length, surface charge density divided by surface or area, and volume charge density divided by volume. Similarly, we can use area, length, another one is volume. So when integration is taken or considered over entire surface, that means area, that is said to be surface integral. When integration is taken over the entire line, that is said to be line integral. And if integration is taken over volume, that is said to be volume integral. These theorems are used, that Gauss divergence theorem and Stokes theorem are used to interlink between or connect between or convert from one type of integration to another type. When we need to convert from surface to volume or surface to line or line to surface or line to volume, we need to use these theorems. So Stokes theorem and Gauss divergence theorem, these two are very important in mathematical physics. So Gauss divergence theorem states that A dot ds, if any vector A is there and its surface integral is given A dot ds, then this must be equal to div A dv, divergence of A, that is del dot A dv, integration over v. That means if we need to convert from surface to volume integral, if anywhere it is written like A dot ds, just like electric flux, E dot ds, integration over S, that is surface integral. In place of E dot ds, we can convert this term into volume integral by this formula. So divergence of A and dv. Here you can see area is a vector quantity, so I have written dot product here, but volume is a scalar quantity, just simple multiplication of dv. So Gauss divergence theorem is used to convert from surface to volume integral. We will use these theorems in next video or later videos where your doubt will be cleared. Okay. Another formula is that Stokes theorem. So Stokes theorem is line integral and surface integral. So A dot dl, if line integral is there, integration over C closed path, that is it will contour or length L, then this will be del cross A, del cross A ds, integration over S. So the conversion from line integral to line to surface can be done by using Stokes theorem. A dot dl equal to del cross A ds. A dot dl, Ampere circuit law, you remember. B dot dl, integration over C. Clear? So this is line integral. If we need to change, because in integration we will equate LHS equal to RHS only when both sides will be same type of integration. Both sides will be line integral, both sides will be volume integral, both sides will be surface integral. So in order to convert from one type of integration to another type, we are going to use Stokes theorem and Gauss divergence theorem. So Stokes theorem is used to convert from line integral to surface or surface to line, and here it is used to convert from surface integral to surface to volume. I hope this is clear. So there are some numericals for you. For gradient, we have 4 questions. For divergence, we have some questions here. Take note of these questions and do all the numericals. This is pi by 2. Here you can see it is pi divided by 2, pi by 2. Okay, these are some questions. Similarly, next page also we have some other questions. Here also divergence questions and curl questions. All these are I cap, j cap, k cap. Okay, I cap, j cap, k cap. All these vectors. Everywhere where I cap, j cap are written, that is cap. I cap, j cap, k cap. Similarly here also. Okay, do all these numericals on gradient, divergence and curl. Practice all these numericals. These are very important numericals. If you face any problem, please let me know in the comment section. Okay, we will meet in the next video. Thank you.